Today we're going to be working with true, false, and logic statements. True, false summary. A statement is true if it is true for all cases. So if a statement is true, it is true all the time, every time. There's no case where it is untrue. A statement is false if it is false at least once. It does not matter if some cases are true. So if it is ever false, it will be false. So even if it's false just one time, it's false. A counterexample is an example that contradicts a statement. It shows that a statement is false. It only takes one counterexample to show that a statement is false. Counterexamples should be as specific as possible. Counterexamples may be verbal, drawings, etc. Quantifiers such as some, all, or none can be used to change the truth value of a statement. All right, and let me give you an example of a counterexample. A counterexample, again, is any case where the statement is false. So you could say that there are 30 days in February. That statement is false because there's only 28 days in February. All right, examples. Determine if the following statement is true or false. If it is false, give a specific counterexample and then rewrite the statement to make it true. Our first statement says, all gasoline is sold by FINA. That is true in some cases, but it's not always true every time. So other companies sell gasoline. This is false. And because it's false, I need to give a counterexample. My counterexample is that Texaco sells gasoline. So I will write my statement. And the rest of the directions told me to rewrite the statement to make it true. So I need to rewrite all gasoline is sold by FINA. What I need to do is take out the word all and change it to some. Statement 2. The square of a number is always positive. The square of a number is always positive. This statement is false also. It is false because of the number 0. 0 times 0 is 0. 0 is neither positive or negative, so this is false. So for my counterexample, I need to say that the square of 0 is neither positive or negative. To fix the sentence, I need to take out the word always. So I'm going to take out the word always and put the word sometimes. Now that you have an understanding of true and false, consider the logic statements and or, which couple two or more statements into one. And or operators are used extensively in electronic applications. A common nursery rhyme starts out, Jack and Jill went up the hill. As an and statement, this is expanded to Jack went up the hill and Jill went up the hill. For the given statement, Jack went up the hill and Jill went up the hill, there are 4 possible scenarios that could determine the truth value of the statement. The scenarios are summarized in the table below. Use the information to determine if the statement is true or false. Truth value of Jack went up the hill. Truth value of Jill went up the hill. Truth value of Jack went up the hill and Jill went up the hill. Jack went up the hill, true. Jill went up the hill, true. The truth value of Jack and Jill went up the hill. Well, if Jack went up the hill, Jill went up the hill, then they both went up the hill, so Jack went up the hill and Jill went up the hill will be true. If Jack went up the hill and Jill did not, then Jack and Jill went up the hill will be false because Jill did not go up the hill. If Jack did not go up the hill and Jill did, then Jack and Jill went up the hill will be false. If neither one of them went up the hill, then Jack and Jill went up the hill will be false. Out of the 4 possible cases, which ones were true and why? Well, only the first one was true because they both went up the hill. Out of the 4 possible cases, which ones were false and why? The statement is false when at least one of them does not go up the hill. All right, moving on to number 5. Based on your findings in the table, consider P and Q, where P and Q are statements. Describe the conditions that make P and Q true in terms of the truth values of P and Q. P and Q is true if both statements P and Q are true. So think about the Jack and Jill. It was only true Jack and Jill went up the hill if they both went up the hill. So that's what they're referring to, something like that. So P and Q is true if both P and Q are true. Based on your findings in the table, consider P and Q, where P and Q are statements. Describe the conditions that make P and Q false in terms of the truth values of P and Q. So this is when only one or neither Jack and Jill went up the hill. So it's that kind of scenario. P and Q are false If either P or Q are false, or both of them are false. Right? So if it's false if one or both are false. Now consider the statement as an or statement. As an or statement, it's expanded to Jack went up the hill or Jill went up the hill. Now consider the statement as an or statement. As an or statement, it's expanded to Jack went up the hill or Jill went up the hill. Again, there are four possible scenarios that can determine the truth value, true false, of the statement. The scenarios are summarized in the table below. Use the information to determine if the truth value is true or false. So this time we're seeing if Jack or Jill went up the hill. All right, our first statement. Jack went up the hill, Jill went up the hill. Did Jack or Jill go up the hill? Yes. This will be true. Right. If Jack went up the hill and Jill did not, did Jack or Jill go up the hill? Yes. This is still true. If Jack did not go up the hill and Jill did Jack or Jill go up the hill? Yes, this is still true. If neither one of them went up the hill, then Jack or Jill went up the hill is considered false. Out of the four possible cases, which ones were true and why? So for our answer to number 8, the answer to number 7. Out of the four possible cases, which ones were true and why? The statement is true if one or both go up the hill. Out of the four possible cases, which ones are false and why? The statement is false when neither go up the hill. All right, number 9. Based on your findings in the table, consider P or Q, where P and Q are statements. Describe the conditions that make P or Q true in terms of the truth value of PQ. All right, so we'll need to answer question number 9. And to answer number 9, we're going to say P or Q is true when one or both statements are true. Based on your findings in the table, consider P or Q, where P and Q are statements. Describe the conditions that make P or Q false in terms of the truth value of P and Q. To answer this question, we need to say P or Q is false. When neither statement is true. Okay, moving on to our next page. True, false, and logic statements. Logic statement summary. An and statement is true when both statements are true. An and statement is false when at least one statement is false. An or statement is true when one of the statements or both are true. An or statement is false when neither statement is true. Truth tables can be used to summarize conditions that make and or statements true or false. Okay, we need to fill in our truth tables for and statements and for or statements. For and statements, when P is true and Q is true, the and statement is true. When P is true and Q is false, the and statement is false. When P is false and Q is true, the and statement is false. When both are false, the and statement is false. The or truth table. If both P and Q are true, then the or statement is true. If P is true and Q is false, P or Q is true. If P is false and Q is true, then the or statement for P or Q is true. If both are false, then your or statement is false.